Hi everybody, so my name is Olivier Anjero, and right now I'm working in Osaka Prefecture University, so as a research assistant professor, and I would like to show you a bit some research we are doing in the university. So I will start with a short introduction about myself, and after I will introduce you a little bit what is affective computing and different kind of application that we can do about like machine learning or AI, affective computing for education or entertainment. So maybe as you can hear, I'm French. I grew up in a very deep countryside of France, in Dordogne, and after I moved to Bordeaux, where I did engineering school and later a PhD in computer science. And since 4 years, I moved to Osaka for working on a current project in the university. And some of my hobbies, so in university, I play with some students, music, rock, and also I enjoy traveling and taking pictures. So, about my working experience, I did my PhD in Labri. It's a big computer science laboratory in Bordeaux. And at the same time, I was working for a company actually, so where I did a bit of research and development for digitizing company. So at that time, I was doing more like pattern recognition, machine learning for image and text, so like document analysis, clustering, and stuff like that. And then I found a nice position in Osaka Prefecture University, where I'm currently working as a research assistant professor. And also I have some connection, so I'm invited researcher in KMD, in KO, since a year, because we have some collaboration with them. Okay, so if you don't know what is affective computing, it's actually nothing complex. It's a bit old, and maybe she's the most important researcher in the field, Rosalind Picard from MIT. And she started more than 20 years ago, this research. So the idea is to try to analyze emotion or some kind of mental state information about the people in order to adapt the technology, the interaction or robot, so to your emotion, for example. In order to do this, we need to use some sensors. So it can be a camera or microphone or some other kind of sensors that I will introduce you after, in order to try to guess what people are feeling. So either it can be based on your facial expression. For example, if you smile, I can guess that maybe you're happy, but I can be wrong too. So you can fake and from audio also, we can analyze the tone of your voice and detect that you're a bit stressful, for example, or something like that. And also there are many physiological sensors that maybe I will talk a bit more later, like to measure your heartbeat or if you are sweating or your skin temperature and stuff like that. So by combining all this information, we can try to detect your emotion, or like if you are engaged or not, or some information like that. And there are many applications. So me personally, I'm interested about education, e-learning system. But there are many other applications. So you can use it also for video games. If you detect that the player get more and more stressful, then maybe it's a good time to do something. Or for movies or social robots, and also for medicine. So there are a lot of applications to try to track the activity, for example, of some people, and to detect if they might be depressed or something like that. So here there are some examples of some sensors that we are using in university. We are using EEG, electroencephalography, so it's kind of device to analyze the brain activity. We are using also just simple camera, like RGB camera, and with that you can analyze, for example, as here the body posture of the people or the face expression. On the right here, it's kind of a smart watch that is so it's made by the MIT. It's named E4, and with that you can measure the physiological sensor, like if you are sweating or the heartbeats, the skin temperature, and also there is an accelerometer to know about the movement. We are also using thermal imaging. So there are recently some researchers use a thermal camera to analyze the cognitive load. So if you are thinking hard about something, the temperature of your forehead will tend to go up, and the temperature of your nose will go down because there is a blood flow coming from your nose to your head. So by using this camera, but it's quite expensive camera, we can detect like this kind of mental state. Like the student, for example, are thinking hard about something. And we use also just the input, so the interaction like mouse movement or typing. And especially eye trackers. We use a lot of eye tracker. And only recently actually we start to use this other device. So today maybe I will focus a bit. I will show you a bit what we do with eye tracker, but if you are interested, after I can tell you a bit more what we do with these other devices. And this is a kind of information that we can try to estimate from. So we do some experiment with, so especially as I say, for example, with the student. So we have a project where we analyze how the Japanese students are reading English, and we try to predict, for example, if they understand or not what they are reading. Or after there is a question, and we try to detect if they are confident when they answer the question. So the cognitive load, I talked already about it. Fatigue and alertness, it's more in Keio University. They are doing this by analyzing the blink. So also from the eye, we can analyze the frequency of the blinks and detect if you, for example, fall asleep or not. So if you are attentive, you should blink less because you try to get more information. But when you get tired or something, you will tend to blink more. And there are even some research, so not done by us, but showing that by analyzing also the eye movement, it's possible to estimate some personality traits. Okay, so now I will show you some applications, some research we are doing right now about education, and after some about entertainment. So for education, actually, I'm hired on this project. It's named CREST. It's a big national Japanese project. There are only few researchers who succeed to get this kind of project in Japan, and Professor Kisei in Osaka Prefecture University. Actually, it's his second one, and it's 5-year project. This one he named it experiential supplements. So his idea is he want to try to make some supplement, a bit like food supplement. So if you need help to learn something, you could get some help somehow. And his idea is to like record the experience from other people and try to use this experience to share with other people. So for example, if I succeed to learn or to do something, maybe the way I practice in order to be able to do this, I could share this experience with someone else. So in order to do this, we need to use a lot of machine learning and sensor to analyze the behavior, affective computing, and more recently we're also interested about cognitive bias. And myself, I had a short project. I got a grant from GSPS about a project I called Smart Documents, where my idea was to analyze the content of documents. So for example, from the text, I can guess if the words are frequent or not frequent, so if the text is a bit difficult for a foreign reader, for example. And on the other hand, I analyze the reading behavior, like the eye movement of the student, and by combining both of this information, I can develop some system, like for example, recommender system. If I see that the difficulty is too hard for the student, that maybe I will try to find another text that match his skill. And in the future, also, so there are many researchers working on text simplification, for example, and also I imagine we could do the opposite to try to practice your skill, to complexify a little bit the text using some bit more rare vocabulary or something like that, for example, to practice vocabulary. Okay, and so I can show you a little bit the eye tracker, what kind of information we get from the eye tracker. So this is a typical recording. So eye tracker is just a camera. Like there are many different kind of glasses, or the one we use a lot is it's just a bar that you put on the bottom of your screen. And recently there is a company named Toby. They produce this for gaming purpose. So like if you move on the right, the camera will move on the right. If you move your eyes on the left, the camera will move. And this eye tracker is quite cheap actually. It's like 100 euros, so maybe $130, something like that. And well, if you want to use for research, you need to pay some license. But it's interesting because it's not that expensive. Like maybe 3 years ago, or no, a bit more, like 5 years ago, you needed to pay like $10,000 or $20,000 if you want to buy a professional eye tracker. But now almost anybody can buy an eye tracker. So this is an example of one student reading English text. So what you see here is actually when you read the text, your eyes are not smoothly moving along the words, but it's more it's a succession of fixation and saccade, so kind of jumps, small jumps going along the text. And what's happening is if there are some very small words and that are very frequent in English, like in, of, your eyes will tend to not stop on this word. So they are just there is a paragraph over there. So when you fix here, you can see a little bit next to the word. And what you do without noticing is that actually you will maybe skip this word and jump to the next one. So if on the opposite you have a very long word and unfrequent in the language, there is a high chance that you will stop on it and maybe even then one more time. So we extract some statistics, some features from this recording, like the saccade length or the duration. So I forgot to say the size of the circle here corresponds to the time spent on this position. So it's very brief, like maybe 300 milliseconds, 400 milliseconds, something like that. And by analyzing some statistics, also like the number of times the student go back or something like that, we are able to predict his skill so here it's a Japanese student reading English. We can predict their skill when they read English, like TOEIC score. We also, on the other hand, try to predict the text difficulty or which specific word, for example, is difficult for the reader to understand. And also we did some application about detecting the confidence. So it's a multiple choice question, like you have one question, multiple choice answer. So you have one question and 4 answers. And based on the behavior, like here you can see the student on the right, he reread a lot and he go back and forth a lot. And another student is quite quick for taking his answer. So based on this, we can try to predict the confidence. And what is interesting is when you combine this with the correctness of the answer. So for example, this student, maybe he answered correctly, but he was really not sure about his answer. So we can still recommend him to review the corresponding part of the lecture. And even more interesting is that the student who is confident but give a wrong answer. So he have maybe a misconception about the lesson. Okay. And right now I'm trying to developing an application that I call Vocabulometer. So the idea is to log the reading activity, which word the students are reading during the day. And so based on this, I can know like which word he read at which time, and I can try to build a model of the reader, so I can know like what kind of vocabulary he tend to read, when he read this word the last time, and how many times he reads the word, something like that. So also I can guess a bit his interest and his skill based on the size of his vocabulary, for example. And then I would like to make, for example, a recommender system to, like every day, propose to the student to read a news or something that could fit his skill and his interest. So there are some research in linguistics showing that if you know 95% of the word of a text, there is a high chance that you can understand the text, and it's even more interesting because you can guess the meaning of the remaining words. So I want to use this trick in my app to, little by little, increase the vocabulary of the student. Alright, and some other research we are doing in my lab. We have people working on manga image analysis. And the question I asked to the student is, what can you imagine? How could be the manga in the future? So I pick up this video because I feel it's very interesting. So it's all like manually done. Some micro animation, some you can also have the 3D movement by moving the tablet. So if you are interested, there is the app. I can give you the link. You can try this. And my idea would be that can we help to generate automatically or semi-automatically this kind of content? So based on a static image, are there some tricks that I can use in order to create something like that? And another example I feel quite nice is to have maybe a VR, so what reading or watching is not anymore reading, manga in VR. And also making some animation or even some sound. So with machine learning, I can detect like there is an explosion or something, and I could try to augment the media, for example, or making vibration or something like that. So this is the research we are doing right now. One which is really hard is 3D depth estimation. So there are many researchers working on picture. So if the input is a picture, a single picture, it's possible to detect the depth. So which part of the image is on the foreground and which part of the image is on the background. And we want to do this for drawings, but it's much harder. So this is like ongoing research. But what we have done and published already is the face detection. So detecting where are the eyes, mouth, chin of a character in a manga image. And I will show you after what kind of application we can do with this. Also, we can try to detect the emotion of the character, and we could try to, for example, change or make some animation. And also detecting the posture of the character if we want to make some animation. And also I'm interested about storyline, to analyze not only like one image but the whole book, whole manga. And so many researchers are using the natural language analysis, so it means like analyzing the text. And for example, on this website, they are analyzing some books. So I think this one is Romeo and Juliet, and this axis is happiness in the book. So you can see that at the beginning everything is going well, but little by little less and less. And you can see here, but actually this is the word. So you can see that from here the word death, poison, and I forgot. Yeah, tears is going up, and other words like love are going down. So this is how they compute this kind of curve. And in my lab, we try to detect from the image the genre, like is it action or romance or comedy. So if you can detect the character is fighting or crying, for example. And there are some software that you can use, also it's from ex-researcher from MIT, like Affective, analyzing the face of someone who is like reading or watching a movie. and try to detect if the reader is happy or sad when he's interacting with your content. And you can also try to plot a kind of happiness curve. So this one is based on the content, and this one is based on the people who interact with. So I think after I want to try to find like the correlation between these two. It can be interesting. What we have done is to use the watch I showed you before, so analyzing like sweating and skin temperature. And in the experiment, we ask our students to read 3 kind of manga. One is comedy, one is romance, and one is horror. And you can see that when the students are reading a horror, so this is the temperature of the skin, is going down when you feel kind of stressful. And if you feel comfortable, it will go up, or it will be kind of flat. And if you analyze the sweating, you can see also like if it's horror, sweating maybe will go up a little bit. So that's about storyline. And I think it's my final slide. So this is quite fun research, also not done by us, but by some other people, where they analyze like the pose of someone in a video, and they try to apply this posture on other people. So they call this video "Everybody Dance Now." So they ask the people to try to reproduce, and after they transfer the pose from the video directly to them, and it works. I feel it's quite impressive to see how it works. So my idea would be to do something maybe similar, but we can do maybe for the manga or for drawings. And we actually started. So this one have been made by my students. So it's a static manga character that he took from a book, and he tried to make the animation by himself. He take a video of himself and say a word, and then transfer this movement to the character. So he was saying maybe konnichiwa or something like that. Alright, so I finished. Some of my research interests here: machine learning, artificial intelligence, and try to use it for education or entertainment. And I think there are many things we can do. From one side, to analyze our behavior, like the human behavior, and to try to help us to learn something also, for example, or to create something. And on the other side, to try to augment and to make like smarter document or smarter creations. So if you have some comments, ideas, and also recently I'm interested to maybe do some startup based on some of this research. So feel free we can talk a bit now, and also you can take my email or Twitter, and feel free to contact me. Thank you.
Question. You mentioned there was a detector that kind of smartwatch takes the sweat and that temperature of the skin. Like, how long do you think this kind of technology or sensor is gonna take to come to like the typical smartwatch or very cheap wristband?
It's a good question, because this watch costs a lot,
right.
And I'm not sure how we can make this sensor cheaper. So accelerometer, the heartbeat also, I think. But the sweating and the skin temperature, I have no idea. Maybe temperature is also cheap, and sweating, might be the most difficult.
So it'll take a while.
It might be. So I'm not much from the hardware, so I'm not sure what are the challenges here. But if we can have in the near future, we can do some nice applications. Yeah?
It's kind of a related question, but I recently read something about IBM got into trouble because they were using people's photos for training their machine learning model for face recognition, and like just random people who had posted their photos to Flickr, and people weren't happy because it might be used by the police or government. Not their photo, but the model, the resulting model. So like, is that a problem that you think about? Like, as if, I guess you use Manga, but it's kind of the same thing. Like if you use a Manga as a training set for your model, do you ask for permission?
Yeah, there are some copyright issues. So here we are a bit lucky because recently the University of Tokyo, they published a data set. I don't have in my slides. They published a data set of it's named Manga 109. So there are 109 books, and which are available for research. So we can use for research only if we want to do some market application. Yeah, I'm not sure, but if it's possible or not. But yeah. Also, it reminds me recently some students from France they make some painting with AI and they sold it like $300,000, and the code was even not their code. Like they use open source code of this kind of there are real ethics question behind this, and it's important to think about it. Yeah.
I think in that IBM example, the photos were like in Creative Commons, so they were free, but at the same time, people made them free for just to be seen and browsed, not to be used for some other thing. So
it's quite interesting. Yeah, please.
You talked about interpreting the feelings of the character on manga, and is it harder or easier than distinguishing the feelings of a real person? Because I would imagine that there's a lot of difference in drawing style and proportions, and how would it make a difference?
It's much harder on drawings because there are such a large variety of drawings, and also not so large data sets. So the problem is to do this, we need models. So we hired people to draw. So to give example, where is the eyes, where is the nose, where is the mouth, and they label like this. I forgot how many, maybe 1,000 images, and after we use this to make our model. But for pictures, there are huge data sets that you can use with. It's very robust. Also, the human face cannot have such large deformation. Or in manga, sometimes you have not really human, but like half monster or half human, and in these cases, our model will not work. So if the deformation of the face is too large, if there is only, also we have problem like if there is only one eye or something, there are a lot of issues here. So it works on very easy, simple text, something like that. Also the orientation of the face will be a problem, so we need more, but if we have more examples, then we can get also better result for the detection. Also black and white is much less information than color images. Yes, maybe. Yeah.
I was wondering what's so special about the eye trackers. I was wondering if you cannot get like some similar results with a front camera of a cell phone to put it in an app application.
So it depends what kind of information you want. If you want to know where people are looking at on a screen, so some researcher and developer are working on trying to make it with a single camera, a webcam camera, but it's really hard. What you can get is like 3D pose estimation. So with a smartphone, I can know, like I can make a model of your face and know where your nose is pointing at, for example, and I can have a rough estimation of where you are looking at, because usually we align our face with the place we are looking at. But if I want to know the detail of your eye movement, for now the estimation have too large error. So we need to use this eye tracker. And the eye tracker, actually they have two cameras, and there is also the infrared light. The infrared light is reflected by your cornea, by your eye, and then it's very easy to segment, so to do also the processing to find because it needs to be very accurate.
Would that work on the size of a smartphone though?
Sorry?
If you had these two cameras on a smartphone, would you be able to do it on this kind of scale?
Yeah. And also the latest like iPhone, there is also the infrared light, so maybe I think in not so long future it can be possible. So it's already possible, but it's like we just know if you look at the top or the bottom of your smartphone, something like that, or left or right. But it's hard to get more detailed information about the exact position. It's ongoing. Yeah. Yeah. Sorry. Yeah. Please.
At the beginning of the presentation, you were speaking of medical application, and I've seen in particular autism.
Yeah.
It looks to me like.
So I saw some research where they use an eye tracker. So it's a wearable eye tracker, kind of glasses with so there is a camera inside the glasses, and what they do is they analyze the eye contact of a young kid with adult people, and if the kid who have autism, they tend to avoid the eye contact and look down. So this is a kind of information that we can analyze to detect this. Or in my context, for example, I analyze the reading activity. We can detect the dyslexia or something like this because the eye movement will be different. Yeah, sorry.
Just two questions. First of all, just to come back to the camera, temperature camera. I just wonder what is the temperature difference you can analyze to see whether someone is seeking very high.
This temperature difference is like 1 degree, or it's about a degree. So it's not it's not 20 degree difference between your brain and yours.
Okay.
So this is why you need like very high accuracy camera to detect these small. It's quite small changes. Yeah.
Okay. And the second one, you about mental state estimation.
Yeah.
You talk that you can make some detection of personality traits.
Yeah.
Which one, for example, can you tell?
So there is a research paper where they try to analyze. It's called the 5 big traits. So I forgot the name, but in psychology there are like 5. Yeah, 5. Like if you are curious or if you are. I forgot the other ones. And like they wear eye tracker during a week or two, so it's also like wearable eye tracker. And by analyzing, also like I say, for example, the eye contact or the eye movement during the everyday life, you can estimate this kind of things. Thank you. Yeah.
Regarding the reading example, if you can come back, I have 2 questions. So
Like the eye tracking.
for the reading, this one here. So your text is linear, right? But the gaze is slightly varying in position. So how do you actually connect the gaze to the actual words? Do you have a model to connect?
So there is. It's a good question. So actually, I said I'm using a kind of low-cost eye tracker, like $100 eye tracker. And the problem with this eye tracker also is accuracy. So I say on smartphones there is no way, but actually even on this side of screen, if the font is small, we will have a mismatch and on a vertical axis, like this axis. And this is why you can see we put extra blank, extra space between the lines to be sure to know which line of eye gaze match with which line of text.
You project the gaze into the 2 dimension afterwards?
Yeah.
Okay.
And after so the error of the eye tracker is large in the y-axis. In the x-axis, usually it's not so. There are not so much error. So it's quite easy to match on the x. The problem we have usually is on the y-axis.
Second question, you mentioned so you can detect some kind of patterns related to how well they understand something or how the confidence about reading and stuff like that. But is it possible that there are minds that work differently and that your model couldn't be applied to everybody the same way?
Yeah, totally. So it's not 100% accuracy, and there are very interesting research. So in our research, the students are all Japanese, for example. But if you ask a Chinese to read English or Japanese to read English, the eye movement will be a bit different. And if you ask a French or Portuguese, actually there is studies showing that French and Portuguese will read much more different than Japanese or Chinese, and just a little bit different from each other because of the mother tongues are also
detect their own.
Cool.
I mean, mother tongue.
yeah. So there are many things that can affect the eye movement, the culture, but also like if you're tired or something like that. So yeah, in our experiment, it's kind of uniform population and it works well. But so also, as I say, like if you have dyslexia or something like that, maybe my system will say, oh, you didn't understood anything, but it's not true. It's just that your eye movement is a bit different than other people.
So let's say in the future you have this kind of sensors everywhere. You can detect where people are confident or not confident. Does that open the door to manipulating people?
Yeah. So what we want to do here is to help.
Of course.
But
Other side.
yeah. So that's the risk if you use any automatic system that is not 100% accurate, and in machine learning or AI, you never have the 100% accuracy. So you will have to face this kind of problem.
So
and also,
you
people could try to manipulate. If they know how the system is working, they can fake also. And so some students don't fake, but our system fail because it seems that they are reading fluently, but actually they just don't care anything about what is written, and we missed that. But yeah, by connecting, so we know that maybe this part, even if you are so fluent, you should slow down a little bit around here because it's getting a bit more difficult. So our model is not so complex for now, and it's not possible to do this kind of things. But yeah, it's very easy to trick the system. If you read very slowly, I will think that you didn't understand, and if you read very fast, I might tend to think that you understand. But
no, what I'm saying is, like you were saying earlier, that you could potentially either simplify or overcomplicate the text based on these kind of sensors, right?
Mm-hmm.
So you could imagine a situation where you want to confuse somebody even more than they're confused already. Mm-hmm. So you, by knowing already they're confused, you increase the complexity of the text as they go through, for example.
You mean if I make a mistake? Yeah, I know. If I make a mistake, it will be a problem. So, still we need maybe some like manual function. You can say that, oh no, it was wrongly detected, and I want to have an easier version, not a harder version. If there is a misdetection, it will be quite a problem. Yeah.
I read the article on news several weeks or a month ago, and that said a person developed detecting a good cucumber or something, and he used it for efficiency. And now he doesn't use the system because he is now specialist of the cucumber or something. So developing those software educate ourselves, and we become more intelligent. And now we don't need the system. How about it? Do you still need to know your students, whether the student recognizes the English sentences or not?
I'm not sure if I understand what's the question, but
did you get better at understanding the students' recognition just by programming the model to do that job?
Thank you. Yes.
Did it train you basically in the same scale?
Yeah, no, not really, because it's just like statistics, and it's a problem of machine learning and AI. So you can build very nice models, but it's hard to explain what are the important features or what. So as I say, also it's not because someone read quickly, for example, that he's skillful. And if the next question is how to help, because I cannot force you to read more quickly. It will not make you understand better. So now we just analyze the behavior, and the next step is, okay, now I know a bit what's going on. What can I do to help you? So here is only sensing to try to estimate what's going on, and still we need to find a way to help.
Need to get the result of the
To make judgment on
yes.
on a person, how much data you need.
Well, the more we have and the better the model will be. But for the TOEIC score, it was like we have 2 pages of English, and maybe after reading 3 documents, something like that. So maybe if you read for 10 or 20 minutes. So if you read only one sentence, it will be very hard to make an estimation, or it will be maybe accurate for this single sentence, but it will be wrong for other texts. So
By the way, would it be legal for, let's say, a company that want to test somebody's English level to make them read on the screen without telling them that there's sensors there? You see what I mean?
yeah. Well, that's. I think it won't be legal. So it's the same problem with camera. It is actually camera or any other sensor. If you want to use this, I guess you need to tell the people. Yeah.
Maybe in the future when you have the license agreement for iTunes.
Yeah.
No, we didn't read it.
But some company ask us, if it's possible to do this, because it's a big problem that people just say yeah, and after actually they didn't read anything. So even without a complex model, it's easy to see that you didn't read anything. Well, just you can use the time and you know that they didn't read anything. But it's kind of signature also, like to prove that you did and you understood. So we don't have the proof that you understood, but at least, for example, that at least you read the text that you are supposed to read. Or to make some people use it to make some annotation also, like to see how I created the document and how people are interacting with my document. So maybe many people read the introduction and after they stop because it's so boring, or I don't know, or they focus on some specific part. It's good to have such kind of feedback. So for the textbooks, for example, it's quite good to know. So without eye tracker already, you can collect some gross information, rough information about which student access the document and which page and how long, for example. But without the eye tracking, it's hard to know how they interacted with the page. Maybe they just open and go to do something else. So it's good to have some other modalities to enrich this kind of progress. Yeah?
In the smartphone, the sensor of the iPhone is too small, the screen. But Apple brought us for the new iPad, that is 13 inches. Mm-hmm. Maybe they will bring to the Mac. So do you think the same sensor will be able to do this kind of thing in the Mac or not?
The problem is not only the size of the screen, but the fact to have only one camera.
It doesn't have two?
So 2 cameras, and also you need the infrared light, and so if there is everything, maybe it's possible. And as I say, also some people are working now with only one single RGB camera, and the accuracy is a bit lower, but it's possible to do something.
Come back on the maybe first question, something else. You're mentioning about detecting the personality traits of the people just by recording several aspects, the face, expression, the voice, and everything. How well would that work with actors, for example, who try to mimic different characters?
So this is the basic research about, for example, I don't have here, but the face detection. If, for example, if you use the Affective, so you can detect a smile, but smile doesn't mean happiness. Or you can detect I look sad, but it doesn't mean really what I feel. But if you start to combine with other sensors, like I feel that your heartbeat is going faster. Heartbeat is a bit more hard to control. So yeah, by collecting more and more modalities again, you can make a better model. And yeah, the most easy to fake, and it's good because there are many situations where we don't want to show our real emotion. The face is not enough. So yeah, also in case of ethics, we need to know that is it okay to like detect your emotion, and do you agree? So in some case, like medical application to help autistic kids to understand what is my emotion, so that, for example, I can make a display and to help them to understand what's going on. It can be nice, but there are many other applications where I don't want to share this information.
Yeah, one more question. Do you actually open source any of the work you do in terms of models?
Yeah. So some data sets, for example, for the manga, the face detection, we open, and also for some eye tracking software and some eye tracking data sets we are also open. But yeah, it's maybe not so nice code, it's kind of research. So, but yeah, if you are interested, like also there are the research papers. We always explain at least the algorithm. So you can find it in the paper if you check on my Google Scholar, or I can send you the links. And yes, not always, but sometimes also the code is making available.
Thank you very much.
Thank you.